All right, let's get started today. I want you to go ahead and note a couple things in your notes, a couple of angles we need to talk about. We're going to start getting out of boring right triangles and how do these actually apply to real life, for instance. When I was in college physics, we had a night lab, and one of our lab responsibilities was to calculate the height of different buildings on campus. We were given a protractor and a yardstick. And I think we had a tape measure as well, but you couldn't measure heights that way. So what we were supposed to do was we were supposed to measure a certain distance, whatever distance we chose, from the base of the building, use the meter stick to sight the angle to the top of the building, and use trig ratios to calculate the height of the building. We were supposed to do that for various, so we were running all over campus, because it was a 2-hour night lab, and so it's dark. And we're wishing we had, laser pointer, because that could be even more accurate than the yardstick, And, so people, coming and going, different, fun activities that people do in the evening that we're not doing because we're in a night lab. And we're down there on the ground sighting the protractor and stuff, and they're looking at us funny. Well, as you sight, for instance, looking up at something, for instance, this is Ethan, and as Ethan looks up, for instance, to the top of the building, we call this the line of sight. It's because it's the line that he uses as he sees the top. But we would call straight in front of him at eye level his horizontal. Does that make sense? So we have the line of sight, the horizontal. This angle above the horizontal going up is called the angle of elevation. You'll write that term down in your notes. The angle of elevation. This is an upward angle from the horizontal to the line of sight. An upward angle from the horizontal to the line of sight, the angle of elevation. And you use this all the time. And right now, when you look at me, you have to use that because your head is lower than my head. So if you make eye contact with me, you are looking slightly upward. There is an angle of elevation. If you look straight in front of you, you're probably hitting the chalkboard right about here. As you look up to my eye level, there's a certain angle that's formed. Make sense? Okay? So since elevation means uplifting, as you look at me, you are all uplifted. Angle of elevation. Now, if there were somebody laying on top of the building, okay, and looking downward at Ethan.
That's Chris.
Looking downward at Ethan. This would also be his line of sight, but horizontal, of course, would be straight in front. If we were to look at this downward angle from this person's horizontal downward along a line of sight, this is called an angle of depression. Because frankly, Chris gets depressed when he looks at Ethan. All right, angle of depression. I use an angle of depression all the time to look at you guys. Just saying. All right, so the angle of depression is the angle between the horizontal, which my horizontal will be right over the top of your heads, and I look down to make eye contact with each of you, angle of depression. Now, interestingly, not interesting, but observing, horizontal and horizontal are always going to be parallel. Therefore, the line of sight functions as a transversal, making the angle of elevation and angle of depression alternate interior angles. And from geometry class last year, alternate interior angles are equal. So if you know the angle of elevation, you also know the angle of depression. Make sense? Looking in your textbooks at page 27 now. Looking in your textbooks at page 27, we see a little guy down on the ground. He's gawking at a hot air balloon. Wondering if that's the hot air balloon with, what was that stupid wide receiver? Michael Brown? No, not Michael Brown. Antonio Brown. Antonio Brown was the stupid wide receiver who flew in a hot air balloon to practice because he wanted to just be cool, and he ended up getting frostbite in his feet or something and had to go have therapy. Anyway, he was a dumb guy. Anyway,
he just won a Super Bowl with the top rating.
Sort of. He didn't play. Anyway, so in the Super Bowl?
Yeah.
I don't remember him catching anything. Maybe I just purged it from my memory. Anyway, line of sight, right? Guy in the hot air balloon looks down, angle of depression. Guy standing on ground looks up at hot air balloon, angle of elevation. They're equal. Good to go? Questions? Look at the example problem. Read the example problem for us, if you would, Jamie.
An observer is 50.0 feet from a flagpole on level ground. From a point 65 in above the ground, the top of the pole is sighted with a 30-degree angle of elevation. How tall is the flagpole?
All right, so you see the little sketch there in your book. I'm going to put it on the board anyway. Flagpole. ground, person, horizontal. And it says the horizontal is 65 inches above the ground. So this is a 5'5" to the eyes, probably a 5'7", 5'8" person, okay? He looks up or she looks up, whatever it is. Doesn't say, it looks like a man wearing a tie, so I'm gonna go with he.
It's a man.
It's definitely a man, a very small man. In fact, it looks like the same man who was looking at the hot air balloon before, except he wasn't facing the hot air balloon.
Same height as Quentin. Same height as Quentin.
Anyway,
I'm a little bit taller.
a little taller than that. All right, so we have line of sight says 30-degree angle. Now, so this is clearly not drawn to scale on the board at least. And the question, if he stands 50 feet away from flagpole, how tall is flagpole? The key with each of these problems is to make a right triangle out of it. And frankly, the right triangle should be fairly obvious here, right? We've got our 30-degree angle. Here's a 90-degree angle. Up here in the class must be a 60-degree angle. And this distance right here from eye to flagpole, they told us is 50 feet. So if you know one side of a triangle, you can find the other sides. But I don't care about the hypotenuse, do I? I don't care how far his line of sight is. I only want the height of the flagpole. Now, that means I'm finding this over here. What trig function with relation to 30 degrees will allow me to find this given this, class? Tangent. Now, we could try to use the special triangle, but we know that if this is x times the square root of 3, which gets awkward, and we're going to want decimals anyway, so let's just go ahead and use the calculator and say that the tangent of 30 is equal to the opposite x over the adjacent 50 feet. Cross multiply, what do we get for the x? 28 point who? 86, blah, blah, blah. All right, Timo, put that in the memory of the calculator.
Yeah.
That's how many feet. Or write down a few digits, Ethan. That's my fault. Oh, that's right, you know how to do memories on that. I showed you. You need a refresher on memories?
Store.
And then tap a button with a letter above it.
Do I have to?
You don't have to do alpha this time, just press a button, and that puts that in memory B. Now, when you go to recall it, you're going to do recall alpha B, and that'll bring it back to you. All right, here's the deal. That's not how tall the flagpole is. That's how tall this much of the flagpole is, right?
Yeah.
What about this little piece? How tall is that?
65.
65 inches. I have to add 65 inches to 28.86 blah, blah, blah feet. This almost sounds like physics, right? Are you allowed to add like quantities but unlike units? No. How do we change inches to feet?
Divide by 12.
Divide by 12. And when we do 65 divided by 12, we get what, 5.41 something? Okay, add that to the memory value now. And we get the height of the flagpole.
34.284180.
Blah, blah, blah. Rounded off, as you see there, 34.3 feet. Though you could argue 2 6 figs because of the 65 inches, just saying. Anyway, 34.3 feet is what they put. I guess they were going based on lengths. Well, 65 is it length? I would have gone 2 6 figs there. Questions on that? Do you see how we can use right triangles to solve these types of problems? Let's start there with some boring triangles. The bottom of page 27, we're trying to find the angle rho. Only one problem. Rho ain't even in the triangle. But, though rho isn't in the triangle, there's an angle in the triangle that if we find it, we will know rho.
Would that be the angle across from 100 m?
Yeah, the opposite angle from the 100 meters, right? The bottom right-hand angle. Because rho and bottom right-hand angle class have to be equal. Because it says the lines are parallel, alternate interior angles, whatever. So, find the bottom right-hand angle, and that'll give you rho at your seats. What trig function? Anyone? What trig function?
Tangent.
Tangent. Because with relation to the bottom right-hand angle, we know opposite and adjacent, But since we're finding an angle, not actually tangent, but arctangent, inverse tangent, right? Because you need inverse functions to find angles. And let's assume we're going 3 sig figs here, since that's everything they gave us.
60.5, 60.
Ooh, you're upside down. Opposite over adjacent. You did adjacent over opposite.
26.6.
26.6 degrees. Should be what we get. Quentin got it. Jamie got it?
63.4.
Opposite over adjacent. So you're going to take the arctangent of the opposite 100 over the adjacent 200. You got it upside down.
I did that. Oh, I divided the one.
Oh, so yeah, you were trying to take a reciprocal. We didn't need a reciprocal here. We just needed an inverse function. That's what happened. Got it now? All right, questions? Look at number 2. We're not solving the whole right triangle. We just need to find x. That makes it pretty easy. What trig function class?
Tangent.
Tangent. Do we need arctangent? No, because we're not finding an angle this time. We'll use plain old tangent. That just equals to number 2.
I got 2.35.
So what are we entering? Write it down. So how do we need to get the x by itself? Alternate. So what do we do? No. This is not tangent equals 23, it's tangent of 23. Those whole things alternate. So we're going to leave the 200. The x comes over here, and the tangent 23 goes down here. Does that make sense? The whole tangent 23 alternates down. And Ethan, what'd you get?
471.1.
Okay, and then let's go 3 sig figs here.
471.
471
Feet.
feet. 471 feet. How many got 471 feet? Got it now? All right, turn the page. Number 3, they want you to find side y and angle beta. If you find side y first, which you could, do not use it to find beta. On number 5, they want you to find both sides x and side h. Do 3 and 5 at your seats. Both 3 and 5 at your seats. Got both of them finished? Yes, 3 and 5.
Whenever I take the explain what you did on the first one?
Well, for y, you're using Pythagorean theorem.
Yeah.
Oh, yeah.
Because I would. Now, you didn't have to. I guess technically you could have said, no, because you don't know beta, so you can't do that. No. Yeah, you had to use Pythagorean theorem to get y. And then started second guess myself there. And then for the beta, I used adjacent hypotenuse, so cosine, but you're finding the angle, so arc cosine of adjacent 80 over hypotenuse 120. What do we get for side y, class?
89.
Rounded 89 feet. And then what do we get for our angle beta?
67.
48.
Ooh, should be 48 degrees.
Of course.
All right, re-enter it on your calculator. Make sure you've got it now. Arc cosine of 80 over 120. Questions on number 3. Now, number 5 is interesting because of a 30-degree angle. You could go 30, 60, 90, I suppose, especially since the side that was given is your x, if you will, across from the small angle. So if this is x and this is x squared of 3, then 160 squared of 3, you just type that into the calculator and get approximately 277 meters. And then of course here, if this is x, this would be 2x, so double of 160, I can do that in my head without the calculator, 320 meters. Or you could use trig functions. You could look at the 30 and say, well, opposite hypotenuse, so the sine of 30 is opposite 160 over hypotenuse, then alternate. Hypotenuse is 160 over sine 30. And would still give you exactly 320 meters. You could say, well, with respect to the 30, opposite over adjacent is tangent, so tangent of 30 is opposite 160 over adjacent x. Again, alternate, x is 160 over tangent 30. Technically, you could even recognize the right angle here and say, well, if this is 30, this is 60. And you could have done cosine of 60 opposite, or tangent of 60 opposite over adjacent, and cosine of 60 adjacent over hypotenuse. Could have used those even. Yes, sir?
When I typed in 30, you said, are 30 arcs in...
Not arc sine. Do we take the arc sine? No, we're not finding an angle. You use arc sine only when finding an angle. I've noted the angle, it's 30. So don't use arc sine. Does that make sense? And if you try to take the arc sine at 30, it'll say error anyway. So yeah, that'll shut that down. All right, how many got 277 meters and 320 meters? All right, questions? All right, let's take a look at number 7. Go ahead and read that problem for us if you would, Chris.
The ladder on the top of the fire truck needs to reach the roof of a 60-foot tall building. If the bottom of the ladder is 10 feet off the ground, the angle of elevation of the ladder is 70 degrees. Find the required length of the ladder.
All right, so I'm going to go and copy the picture. You see it there already, but you got the fire truck. And those are wheels. They go round and round.
Those wheels don't look connected.
Yeah, I know. All right, so fire truck, light, and shining and siren blaring. Okay? And anyway, so the fire truck ladder is already on top of the truck. So it starts off, it says 10 feet off the ground already. Okay, ladder. So it starts 10 feet off the ground already. And then it reaches to the top of the building, or needs to reach the top of a building. And the building itself is 60 feet tall. That doesn't mean the ladder needs to reach 60 feet. How high does the ladder need to reach, class? 50 feet. It's already got 10 feet to the top of the truck. So we only actually need, right here, 50 feet. Make sense? Now, it mentions that the angle of elevation is 70 degrees. My guess is that if you go steeper than 70, it's not safe to carry equipment up. Okay? So I'm picturing anything steeper than 70 is probably dangerous to the firemen. So they say if our max angle is going to be 70 degrees, okay, how long does the ladder itself need to be? What trig function do I need to solve this, Chris?
Opposite of 100.
So,
Sin.
sine. At your seats. Find the required length of the ladder. Good. How many also had the 53.20, blah, blah, blah? How many sig figs?
2.
2. So we'll round 2.
53.
53. 50 feet. 53 feet. Okay. Questions on that? Do we see how, again, it's not really a right triangle, but we can see a right triangle within the problem. Questions on that? Number 8. Go ahead and read that problem for us, Ethan.
An airplane is at an altitude of 7,000 feet as it approaches a runway and has a 6.5 degree angle of depression. What is the distance in miles from a point on the directly beneath the point to start the runway 1 mile?
All right, so that looks like a little Blue Angel plane there. Well, it's little because it's strong. But anyway, Blue Angel plane coming down for a landing. The runway itself, you notice, starts at that black dot. Okay, that's the start of the runway. Where he is now, that's the question. How far away is he from where the runway begins? He's at an elevation of, or an altitude of 7,000 feet. And if he looks down at an angle of 6.5 degrees, if that's his angle of depression, class, then that's also the angle of elevation down at the dot at the start of the runway. So go ahead and put a 6.5 degree angle down there also. The question is, how far is he from the beginning of the runway along the ground? Not how far does he have to fly. It's not that red line. The red line is where the plane would fly if it came down in a straight line. But how far along the ground? Does that make sense? So what trig function, don't answer out loud, what trig function do we need to use? Now use it, but realize it's going to give you an answer in feet because the altitude is in feet. So if it wants the distance in miles, you're then going to have to convert to miles. So 2 steps. To the problem, going to number 8.
Is it going to be more than a mile?
Oh yes, oh yes. Could be several miles. We are going to have 4 sig figs here. Swing around sides the same, so 4 sig figs. Ethan, how many feet, first of all, is it? It's a big number of feet.
61,000 or 6,000.
No, you were right. You're right the first time.
Yeah, 61,438 feet.
Yeah, 61,438 and some feet, right? Dividing that by the 5,280, how many miles is that?
Well, 11.64 miles.
Good. When we round to 4 sig figs, 11.64 miles. How many had the 11.64? Okay. Did we get the 61,400 whatever feet? We did not. Okay, so plane, wings, tail, okay? He's at a height of 7,000 feet, okay? And if we track all the way down here to runway, it's a 6.5 degree angle, correct? And we're finding this right here. What trig function do we have to use, class? Tangent, right? And we'll say that the tangent of 65 degrees is equal to opposite, what's the opposite?
65.
6.5, excuse me. Opposite,
7,000.
7,000 over adjacent,
X.
x. How do I get the x by itself?
Alternate.
Alternate. X is going to equal to 7,000 divided by the tangent of 6.5. So re-enter on the calculator.
That's a good deal. I did sine into it.
All right, we would do sine if we were finding how far would the plane have to fly to make the approach. But we're not finding that. We're actually finding literally how far is he from where it is along the ground. All right, got it now? All right, again, there got that gives you the 61,000 number, and then divide that by the 5,280.
11.6.
All right, 11.64 if we go to the 4 sig figs here. And good to go now also? All right. Look at number 12 on the next page. Numero 12-0. And go ahead and read this for us if you would, Quentin.
An eagle is flying 107 feet above the ground and with a 56-degree angle of depression. Sees a squirrel in a tree 15 feet from the ground. How far must the eagle fly to capture the squirrel? Assuming that the eagle dies, this is at angle and that the squirrel is paralyzed with fear and does not move.
I love that last line. Assume the squirrel is paralyzed with fear and does not move. What?
Is that why you fixed this one?
I love that problem. I think that's got to be my favorite problem in the entire book. The squirrel is paralyzed with fear. And
I
does
would be
not
running.
move.
I don't know if that's wrong.
Anyway, well, have you ever been driving along, you see a squirrel in the road, and it starts to run one way, and then it starts to run the other way, and then it just freezes for a second, and then you hit it. You're not wanting to hit it, but the squirrel went and ran right, like if it had just stayed put, it would have been fine. But it ran, and then anyway. So the squirrel is paralyzed with fear and does not move. It is about to become lunch. It is the cycle of life. It is how the eagle survives. Do not hate the eagle for it. All right, and definitely don't shoot the eagle because protected species and all. All right, so you see the diagram there. The squirrel is already 15 feet up. The eagle is 170 feet up. So the eagle does not have to descend 170 feet. How far in drop does the eagle have to go, class?
155 feet.
155-foot drop, right? Okay, and if the eagle has a 56 angle of depression, then this paralyzed with fear squirrel, as he looks up and beholds his attacker with terrified eyes.
Depression.
Try not to have nightmares from this. His angle has to be what?
56 degrees.
Also 56 degrees. At your seats, find how far the eagle flies to nab his lunch. And this is why PETA hates you if you kill a squirrel, because squirrels are there for the
PETA
eagle,
like
it's
my
not for
job.
you. No, not PETA as in your job, but PETA. But, whatever PETA stands for.
Easy.
And what trig function do we have to use here, Ethan?
Sine.
Easy.
Yes. I was looking at the top
Easy.
angle. You're right, sine. And when we use the sine, we end up getting what for his flight distance here, Quentin?
You can use cosine too, right?
No.
Or tangent, tangent.
No, because you don't know either. No, you can't.
Why can't you use
Easy.
tangent?
Okay, that's eagle.
141.
Tree, nope. This is the squirrel. Okay, there's his little head, his little tail, and his little feet. Okay, that's the squirrel. Okay,
Looks like a fire.
he's gonna be lunch.
Let's go fire it.
Sorry. And so we know that total height is 170 feet, but squirrel is already up 15 of those feet, right? So this actual height is only 155 feet. We said that right up front. The dive angle is a 56 angle of depression. That means it's a 56 angle of elevation for the squirrel as he watches with terrified eyes. So we have the opposite, and we need the hypotenuse, which is the flight path. Now, theoretically, Chris, yes, could you use the cosine? Well, if you then said that these are perpendicular, so you used a 34-degree angle, you could use cosine.
I did.
But not if you used a 56-degree angle. But yeah, cosine of 34, sine of 56, they're co-functions, they would work. Quentin has amended his answer. How far does the eagle dive?
129 feet.
All right, so Let's assume we're using 56 because we don't want to have to subtract from 90. Opposite, hypotenuse, sine of 56 degrees equals opposite over hypotenuse. Show this step. Don't try to think in your head, wait, am I multiplying or dividing? You're going to get it backwards. Show the step, and now you know you have to alternate and divide to get 187 feet as our answer. How many got the 187 foot answer? All right, so assuming an eagle can dive, I don't know, 90 feet per second, that squirrel has about 2 more seconds of life expectancy. And then,
Well, no, longer.
He jumps off the tree.
He's gonna pick him up and then fly him off to his nest, so he is a little bit longer.
well, no, but that impact of the talons, if assuming he grabs with the claws, right? If he gets him with his talons, the impact in the neck will kill him instantly. So,
Why do you know this?
biology class, I paid attention, didn't you?
No.
No.
All
I don't think
right.
he knows what biology is.
All
I'm
right.
studying biology.
Here's a random fact that nobody needs to know. Look at number 9. And speaking of random that nobody needs to know, Chris, go ahead and read number 9. Hey, I actually thought about picking on Jamie with that one. I just couldn't bring myself to do it. I don't know why.
Because she's your
She
female.
just sits there in my room. No, I pick on
Go down
Kendall
there.
because she's short. I don't know, Jamie. I don't know. All right, so number 9, Chris, read that for us.
The largest escalator in the world is 1,089 feet long, and at the Leningrad Underground in Lenin Square, if the angle of elevation is 10.36 degrees, calculate the work.
All right, so now I haven't actually Google searched this, okay, but I assume Leningrad Underground means it goes under the ground, okay? It's possible that this is a building called the Leningrad Underground, but I think it actually goes underground, okay? Maybe I should Google this after class. But anyway, so we've got, ground level, okay? And then there's this underground city down here called Leningrad. By the way, anyone know where Leningrad is?
Russia.
Yeah, Russia, right? Named after Vladimir Lenin, right? Anyway, so we've got the escalator, right? It's the stairs that move by themselves. You just stand there, okay? So we've got, escalator. It goes down, 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 down. Or if you're already down, it goes up, 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 up. Whatever. Okay, so there's the lower level there. Longest escalator in the world is 1,089 feet long. Okay, that's a really long escalator.
That's probably a 5-minute escalator ride.
Says if it's 5 minutes, let's see, that'd be about 3 feet per second. That sounds about right. Every second, about 3 feet down, maybe, or 3 feet along the path. So, yeah, about a 5-minute ride.
Tell me I'm smart.
10 point, I won't do it. 10.36 degree angle of elevation. And the question is, calculate the vertical rise. How high up are you going? Or conversely, how far down are you going? If you're going down the escalator, that's the question at your seats. And this is the only part of me that makes it hard to grasp this being actually under the ground. Because this is a massive number.
It probably gets hot down there.
No, I'm
It's not that massive. No, I'm really curious. Where's my phone? When in doubt, ask Google.
Google. Where's my dad?
Is Leningrad underground actually under the ground?
Yeah. I thought it was like an underground rap battle scene.
There's an underground railway down there. And yes, it actually goes very, very far below ground. Wow. Okay.
Why are they underground?
Because it's free real estate.
Are they scared of being
Nobody's
bumped?
stopping you from building down there, right?
Are they scared we're gonna drop it on top of the
I don't know. Maybe they were. Anyway, how far down does this escalator go, Quentin? Not that far.
Whoa.
Okay, what trig function, Quentin?
Sine
Okay, good. We need the sine. So we'll say the sine of
10.5
is equal to,
1089.
no. Sine's whatever what?
Also,
What's the opposite?
what we're trying to find.
The question mark. We'll just call it x over hypotenuse. So what do I have to do to solve for the x? Gotta multiply the 1089. You've got to show that step. Show trig function of angle equals and make the ratio. Okay? That'll tell you when you need to use inverse functions, though you know that's anytime you need an angle, it'll tell you which one's over what, it'll tell you whether you need to alternate or cross multiply. So not quite as massive as you got there, Quentin. 196-ish. Let's see how many sig figs are we allowed. I'm gonna go 4 sig figs. 195.8 feet. Now think about this. A typical story on a building is about 10 feet. Okay, 8 foot to the roof, to the ceiling, and then usually about 2 feet of gap between stories for like air ducts, electrical. So 10 feet for a floor. This is about 20 stories down.
16.3197938 3 stories down.
Yeah?
Yeah.
12 feet, 2 for
I said 10.
10 plus 2 for electrical, right?
No, 8 plus 2 for like 10. So 19.58. So basically 20 floors down. And apparently, as I just Googled this, the deepest station, like there's railways that run all under the ground as well, the deepest railway station is 282 feet down, which is about 28 stories below the ground. So,
How do you
yeah.
get down there?
The escalator. And then take the train, which apparently doesn't run perfectly level. Apparently the trains kind of go up and, anyway.
Well, so it's at the limit underground where it's the deepest?
Well, it's sort of its own thing. So yeah, anyway, that's just crazy to me though. So I've heard there's an Atlanta underground. I've never been there.
There is.
Is underground Atlanta?
And also
So I don't think it goes down that deep though.
Uh-uh.
But have you been there? Okay. Do you have any idea about how far down you go?
Not really. It's not that far though.
Yeah, definitely not to
I've been
20
there with my
stories.
brother.
So anyway, if you ever happen to travel to Russia and meet up with Hunter Biden,
No, that's Ukraine.
I just had to get political there, didn't I? All right,
That's China.
let's move on. It's all of them. Anywhere there's money to be had with political influence. Anyway, and laptops that can be left for whatever reason
And
unattended.
emails.
All right, let's take a look at number 13. Number 13. Go ahead and read that one for us, Jamie.
A technician stands directly below a weather balloon. At the same moment, a colleague who is 3.7 miles away sights the balloon at an angle of 27 degrees from the horizon. How many feet above ground is the balloon? How many feet is it from the observer who sights it at 27 degrees?
All right, and reminder that a mile is 5,280 feet. All right, so we see a little picture there. There's the person directly below weather balloon. There's the person who is miles away who looks up. And now we're going to assume, notice the sketch has the dashes, the dashed line of sight drawn to his feet. When you get over that distance, it really doesn't matter if it's drawn to his feet or his eyes anyway. So maybe he's laying on the ground though. Like it shows him standing, but really he's like laying on the ground looking up. Whatever. Okay, 27-degree angle of elevation. Okay, or we just assume he has eyes on his feet, which would be very strange. 3.7 miles away. The question is, how high is the actual balloon? And then, how far, literally, along the line of sight is the balloon from the second observer? All right, so finding both of those answers, the sketch is there in your book. Those are weather instruments.
No one cares about weather. So.
So 2 answers this time. How high is the balloon? How far from the observer is the balloon? So if you were looking through binoculars or something like that, how far is he actually seeing the balloon? How far away is he seeing?
don't they?
They want the answers in feet. So you're gonna have to just change the 3.7 miles into feet before you do the math, would be my recommendation.
Great finished it.
How many feet is 3.7 miles?
19,536.
But we're gonna base our answer off of 2 sig figs. So when we get our answers, we're going to 2 sig figs. Because 3.7 was the given value.
So 20,000.
Not that the answer just yet. I'm gonna call the height of the balloon, the altitude, I'm gonna call A, and the distance from the second observer, I'm gonna call D. All right, Jamie, what trig function do I need to find A, the altitude of the balloon?
Tan,
Tangent. And we'll say that the tangent of
27 degrees,
is equal to,
x over, I put 3.7 miles in between.
and then you convert it after the fact. I'm gonna go ahead and just do A over the 19,536. When we cross multiply, how many feet high is the balloon, Jamie?
It is, what is it, 10,000, 32?
That is not what I got. Chris?
I got it, 8,900.
That is not what I got.
For how high it is, or?
Yeah, that's for how high it is. What?
1.9? You're looking for miles?
Yeah.
I'm looking for feet. That's why we changed this to feet to begin with. Just cross multiply. Tangent of 27 times 19,536.
9,954.
Yeah, 9,954 feet.
Oh, I got it.
However, we have to round this off to 2 sig figs. What does it mean?
1.000
Well, 1.000 would be 4 sig figs.
1.0 E3. E4.
E4, there we go. So we cut it off at 2 sig figs. The 5 bumps the 9 up to a 10, which bumps this 9 up to a 10, ended with 10,000 feet, but that's only 1 sig fig. If we put a decimal, it's 5, so we're going to say it's approximately, move the decimal 4 places, 1 E4, but we need 2 sig figs, 1.0 E4 feet. Should be our altitude. But the initial number, that's ticky-tack points there. The main points is the 9,954 feet.
Somehow I got to the 1.0 E4 feet, but I'm not sure what happened before that or what I did with it.
Well, you would have had a different initial answer anyway, because you would have had miles. Then you would have multiplied by 5,280 to get this number. Theoretically, at least, that's what should have happened. All right, what about if we want to get the D, the distance from the balloon to the observer, Chris? What trig function?
Sin.
Nope.
No. Cosine.
And it's not sin, it's sine. It's spelled S-I-N for the abbreviation, but it's spelled S-I-N-E in words. But cosine, and we'll write what on the chalkboard here?
You're going to write cosine is equals, or not equals, 27 equals, then you would put the adjacent, which is, why can I not think right now? 19,536. I put 3.7, I just changed it after.
Right.
And then over D.
All right, and then what do I have to do to actually solve for D?
Divide by cosine 27.
Good, alternate and then divide by the cosine of 27, and that will give us a whole lot of feet. He's redoing it to make sure he has the right answer.
21,925.
Yeah.
So only
21,925.7. It just keeps on going, right? Round it off.
22,000.
22,000. And then it's already the 3 sig figs. We don't need to do scientific notation. It's about 22,000 feet away from that balloon. All right, questions on this? Did anyone get both of those correct? All right, so Quentin, good to
I
go.
only got one.
Anyone get the second one correct, at least the 22,000, and we had some trouble with the altitude? Questions? Because you're going to have 4 of these tonight for homework, in which you're going to practice using the right triangles to answer these questions. Homework for this evening is to do pages 28 to 29. Pages 28 to 29. Number 4, 10, 11, and 14. Pages 28 to 29, numbers 4, 10, 11, and 14. Tomorrow, here's the plan. We go over the homework. You take a quiz. We grade the quiz. We review.
Jeopardy.
Monday we test.
Are we doing Jeopardy?
No, not in pre-calculus.
No
Reviewing. All right.
game?
Test coming up in lesson 14 over chapters 1 and 2. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.